So it's always fun to do these projects, and every time Ross sends me an email, I always reply straight away.
You do?
Because it's so much fun to do this kind of stuff, to work with authors, and I get a lot out of it for fun personally, as well as for the finished product. So the whole idea was these thought experiments, which in science we use quite a lot. It's a way to play with the science. So we have some beautiful theory of the universe, and we want to explore its consequences and maybe understand what the limitations of it are. So we play these games in our head. We imagine two great scientists writing letters to each other, where one proposes a theory, the other one gets the letter, thinks, but what if a chap came along and this happened? What would happen to your theory? It would mean this would happen. And the other guy would go, oh yeah, you're right. So the theory actually evolves as a result of doing these thought experiments. And there's a lot of famous ones in physics. I think the most famous ones are in relativity. So there's the twins paradox to do with how space-time works, or Schrodinger's cat, which is the most famous one, I think, to do with a little cat in a box, and then is it alive or is it dead? Or in quantum mechanics, it's actually both at the same time. That's a thought experiment that we do to understand the consequences of the theory. And so when I got the email about thought experiments, I was like, there's so many to do, it's so interesting. But then there's a couple that don't have as much press as the others, and they both have devils in them. So I proposed to Ra that we do a story based on these two thought experiments. And the devils are there to kind of play a certain kind of interesting role. They're kind of there to be a little mischievous, if you like. So in one of them, he's there to give us a consequence of a theory that maybe is a bit unpalatable. He's there knowing something, and that's not so good for us. Or he's there to do a certain job and allow us to explore the limitations of the theory. So the two demons, so I chose like nice mischievous demons. I think of a demon in science, doing science with us. Not a little chap with a little fork and a tail, all this kind of stuff. Not that. Some imaginary object or imaginary beast that is doing something in our physical theory. So there's two, and I'll tell you about the physics of them really briefly, and then we can talk about more detail later on afterwards, after the stories. The first is Laplace's demon, and what basically this is, if you imagine some demon, some guy with a trident, and this guy knows the position and the speed of every particle in the universe, because everything's made of particles, and they obey laws. So imagine this demon knew the position and speed of every particle in the universe. He just did. He had a big sheet of paper. Then using classical physics, so Newton's laws of motion, Newton's gravity, all this kind of stuff, he can then calculate, it might take him a bit of time, but he can do it theoretically, the positions and the speeds at the next instant in time. And then again, the next instant in time, the next instant in time. And because his classical theories are reversible, he can go back in time as well. So if this demon, this little mischievous chap, knows the positions and the velocities or speeds of all particles in the universe, he knows what happened yesterday, because the classical laws are obeyed, but also he knows what's going to happen tomorrow, because he can calculate it. So suddenly what's going to happen tomorrow for us is predetermined if Laplace's demon can do this amazing task, which is interesting from a physics point of view. I mean, it's clearly a massive calculation. I think my laptop wouldn't cope with it, but it kind of has something to say about free will. And I think it was the first time anyone discussed scientific determinism in a very concrete way, that if this demon, this mischievous guy existed, then free will's gone from the theory. So I won't tell you how it's resolved. It's thankfully, physics, we hold on to free will, because that's a nice thing to hold on to. There are resolutions to it. But in the story, I think this comes across about free will quite nicely as the story goes on, especially at the end. I think it's really good. The second one is Maxwell's demon. Now this is a slightly different kind of demon. This is a chap who's playing a certain role. So we think there's loads of laws about the universe that everything must obey. And one of them is have conserved energy. That's true. And there's also a law that says, has loads of different formulations, that sounds quite simple, that heat must flow from a hot thing to a cold thing, not from a cold thing to a hot thing. That's the second law of thermodynamics. It has many different expressions. Basically what it's saying is, it's giving you an arrow of time, that hot things go to cold things, not cold things go to hot things. That seems fairly obvious, and a lot of these things often are, but have very interesting consequences. It's also a statement about disorder. So things like to get more disordered. It's called entropy in physics. The universe is heading towards an ultra-disordered state. So if you take a teacup and chip it off a desk, it breaks in lots of little pieces. It gets more disordered. Bits of a teacup don't come back together to form a nice, unbroken teacup. Things like to go to a more disordered state. That's actually the same thing as heat going from hot to cold in physics. So what Maxwell's demon is not two solids, but imagine a hot gas and a cold gas side by side. The little demon sits on a gate between the two of them, and by opening the gate at the right time, he gets energy to flow from the cold thing to the hot thing in apparent violation of this very, very fundamental law. So that was the demon who's being mischievous. We think this must be universally true. The demon turns up, opens a little door at the right time, and is violated in some kind of way. So the demon is playing in a way, it's trying to teach us through a thought experiment, is the theory true, and what are the limitations of the theory? Thankfully, it was resolved. These things often are, and they're quite helpful. So there's demons in both thought experiments. They play slightly different roles, but what they're both doing is helping us do physics, help us explore what's going on, but also they're, in a way, they're stretching us to say, how good is your physics? Is there a way where we can circumvent what you grandly call a very fundamental principle? And also, I hope, they're really good devices to produce good works of short fiction. So that's where we got talking, and then these things came out of it. So I hope, in a small way, I helped to produce some of the stories we're going to hear today.